Hi, welcome back, and thanks for checking into your next math video lesson. We are going to continue on in our unit for finding the volume of three-dimensional figures, and this learning target is that you will be able to find the volume of a sphere or a hemisphere. So when we're talking about spheres, we're talking about like a basketball, right? Something that's three-dimensional and rounded on all sides. A hemisphere is going to be half of a sphere. All right, so let's look first at the volume formula for a sphere. To find the volume of a sphere, volume is equal to 4/3 times the value of pi times radius to the third power. So there are some different things in this formula compared to the volume formulas that we've been working with in the previous few lessons. First of all, one thing that's different is the 4/3. In the previous volume formula, we were doing volume of a cone. The fraction in the formula was 1/3. So make no mistake that this is really supposed to be 4/3. For the value of pi, I prefer that you actually use the pi button on a scientific calculator. If you don't have such a calculator, then you certainly can substitute in 3.14. However, I would much prefer the actual value of pi, which would be the pi button. And yet again, something different is the fact that this is no longer radius squared. It's not radius to the second power. It's now radius cubed. This is radius times radius times radius. So radius to the third power. So once again, it's 4/3 times pi times radius to the third power. And just for the sake of making sure that you remember what a radius is, the radius goes from the center of the sphere all the way out to the edge. And that will be the radius value that you are going to take to the third power. Remember that if they show a diameter that would cut all the way across the center of the sphere, then you would need to take half of that value in order to get the radius that you then would cube to the third power. Let's try some and see how we do. Get your calculators out. Definitely going to want to take some notes here. It says find the volume of each sphere and round to the nearest tenth. Now, we've been doing these sorts of problems, area problems and volume problems, and working with these formulas now for quite a few days in class. You should by now know the expectation. So I expect for that each problem you're going to start by writing the correct formula. You're going to substitute in the values that we need to plug in this case it'll be for the radius, and then I expect to see your final answer with the correct label. All right, so for example, here's a nice sphere that has a radius of 5 inches. So I start with my formula. Volume is 4/3 pi r to the third. I'm going to substitute in my values. Radius is 5, and 5 to the third power is not 15. It's actually 125. So in my calculator, I type in 4/3 times pi times, you could do 5 to the third power, which would be 5 and that little caret button and then a 3, or you could take 5 times 5 times 5, which ends up being 125, and the final answer for the volume of this sphere, after you round it, is 523.6 inches to the third power. Final answer there. All right, not too tough. Just simply writing the formula and plugging in your values, showing your steps, of course. Problem number 2, they are showing a diameter. So you better be on your toes here and realize that the radius is not 8. The radius is actually 4. So here comes the formula. 4/3 times pi times r to the third power. Now I'm going to plug in my value for my radius. Radius is 4 to the third power, and of course I'm multiplying there. And in your calculator, 4/3 times the pi button times 4 times 4 times 4 is 268.1 meters to the third power, or cubic meters. It's really a rather simple formula. It's all calculator work, but you have to be careful that when you're entering your values in the calculator that you don't make any mistakes. Don't accidentally enter 1/3 instead of 4/3, and don't accidentally do the radius squared, because it's really supposed to be radius cubed. Now we switch gears a little bit and we start talking about hemispheres. I told you earlier in the lesson that a hemisphere is half of a sphere. So the formula changes just a little bit, and I'll show you what that formula is here in just a second. And also it says to be sure that we have to round our answers to the nearest tenth. Okay, so for number 3, the volume is going to be equal to 4/3 still, times your pi, times your radius to the third power. But that would be if we had a whole sphere. And we don't have a whole sphere. We only have half of it. So we also need to multiply this by half. So these are all being multiplied together. 4/3 times pi times r to the third times half. All right? Remember, multiplying something by half is the same as dividing it by 2, which ultimately is what we're doing here. We're going to find the volume of the sphere, and then we're going to basically take half of that, or divide it by 2. All right, it's time for me to plug in the value of the radius, and I look over there at my drawing, and I see my radius is 3 to the third power, which is not 9, by the way. It's actually 27. And in my calculator, I enter 4/3 times the pi button, times 3 to the third power, or 3 times 3 times 3, times half, because it's only half of a sphere. And after I round, I get 56.5 centimeters cubed, or cubic centimeters, or centimeters to the third power. Okay, make sure you can arrive at that answer on your own with your own calculator. And this is actually another hemisphere, but they are showing a diameter here. You gotta remember, gotta take half of that, so the radius is actually 7. Formula, 4/3 pi r to the third, then times half. I'm going to plug in my value for my radius, which we decided was 7 to the third power, which is not 21. Punch all this stuff in my calculator, and I do a little bit of rounding, of course. Oops. Always got to round to the nearest tenth. 0.4 cubic feet. Very good. Just following the steps, right? This last one is a word problem, and it talks about, of all things, a disco ball. It says, a giant disco ball has a diameter of 40 inches. Find the volume of the disco ball, then find how long it would take the ball to deflate if it shrinks at a rate of 100 cubic inches per hour. Yes, a shrinking disco ball seems strange. It does, and there's probably really no such thing, but just for the sake of this volume unit and this particular volume of a sphere lesson and the fact that spheres do exist in real life, I thought it would be interesting to calculate the volume of a disco ball and then imagine how long it would take to shrink, if it could, if it was losing capacity at 100 cubic inches per hour. So first, let's just calculate the volume of this thing. 4/3 pi r cubed. 4/3 times pi. What's the radius? It's not 40, it's 20 cubed. Volume of the disco ball is as follows. Pretty big. 33,510.3 inches cubed. Now, the rest of the problem says, How long would it take the ball to deflate if it shrinks at a rate of 100 cubic inches per hour? So basically what we're going to have to do is you're going to take the volume of the disco ball and divide it by the rate at which it's shrinking, which is 100 inches cubed per hour. So on your calculator, you take 33,510.3, you would divide by 100, and lo and behold, it would take 335.1 hours for our disco ball to lose all of its volume and shrink down to basically nothing. If you could even imagine a shrinking disco ball. That brings us to this, the fact that we'll be working on finding the volume of spheres and hemispheres in class over the next few days. All right, I'll see you then.